So hi children, so in that previous video what we discussed, here in that video we discussed about that digits and significant digit, insignificant digit, and in the same way what we discussed here, what is the smallest number and what is the greatest number, and how many n digit numbers are there in all. Okay, these concepts we discussed in that previous video, right? So once again I am asking the question, how many n digit numbers are there in all? Okay, like that questions, which formula we have to use? Yes, if you know that answer, then you have to comment in that comment section. Okay, what is that formula here? 9 into 10 to the power of n minus 1. So here n means number of digits of a number. Okay, a number consists of how many digits? Okay, that one represented by n. So what is that formula here? 9 into 10 to the power of n minus 1. So after that concept, the very important thing, that is place value. Okay, in this video we are going to discuss about that place value, face value. After that we will discuss about the types of numbers. Okay, before going to discuss about the types of numbers, we will discuss about that place value. Okay, so what about that place value? Okay, place value. So place values already you learned in that previous classes, right? In earlier classes you learned about that place values, international place value system and Indian place value system, right? So according to our Indian place value system, ones, tens, hundreds, thousands, 10,000s, okay, lakhs, 10 lakhs, crores, 10 crores, arabs, okay, 10 arabs, and so on. We have that so many place values, we know this one, right? So here what about that place value, how we will tell the definition? Okay, here place value means the product of a digit, the product of a digit and its position, okay, the product of a digit and its position, it gives that place value of a number, place value of a particular number. For example, here I taken one of the number, that is 8564. Okay, what is that number? I chosen here 4-digit number, that is 8564. If you want to read that any largest number, if that number consisting of, if that number also known as a numeral, right? Already we discussed that. Okay, so if a numeral is consisting of minimum 2 digits, then we have to use that place values. Without using place values, we can't read that any number. If that number is consisting of 2 digits, 3 digits, 4 digits, whatever it may be. Okay, if you want to read that any smallest number or the largest number, for that single digit numbers, no problem. Okay, those all are digits and those all are the symbols of a numbers. So we know that how to call those digits. Okay, but what about the 2 digits onwards? 2 digits onwards we have the 2 places now. So if you want to read that any number, if you want to pronounce that any number, okay, mostly we have to use that place values. Without using place values, is it possible to read that any number? Not possible. That's why I told you that this is that very important. Okay, without using that place value, we can't read that any number, no, that's why. Now I want to know that what is the place value of 5 in that given number. Okay, what is that given number actually here? 8564 is that given number. So from this number I want to know that what is the place value of 5. Okay, so how to know that? Here what is the definition? The product of a digit. Digit means which digit place value you want to know. Okay, that digit. So here that is 5. And its a position, means it's a place value, in which place that 5 is there. Okay, just say that ones, tens, hundreds, thousands. Okay, so in which position 5 is there? Yes, 100th position 5 is there. Okay, so that's why 5 into 100th position, so that's why 5 into 100 is equals to 500. So 500 is the place value of that 5 in that given number. Is it clear? So this is about that place value. So in the same way, if you want to know that what is the place value of 8, okay, so again same thing, 8, that is the digit, which digit place value we have to know, we want to know, okay. So that is 8 into 8 is there in which position? Yes, 1000 position. So that is 1000. So 8 into 1000 is equals to 8000. So the place value of 8 in that given number is 8000. Okay children, is it clear? So here this is about that place value. So after that place value, we have to learn about that face value. So face value of a digit means the digit itself. Okay, just I will tell you one example. If you want to go anywhere, then wherever you will go, your face doesn't change anywhere. Is it clear? Yes or no? Okay, if you will go anywhere, either that is your home or school, whatever it may be, wherever you will go, your face doesn't change, right? And in the same way, the face value of a digit never changes. Okay, so what is the face value of 5? Wherever you written 5, its value, its position doesn't, I mean, its position is in different way, but here its value is in same, right? Okay, for example, here I written that 5050. Okay, and here 454. Okay, here this is a 5 is there, and here also 5 is there. The symbol is same. So wherever I written the digit, I will call that digit as 5 only, no? So that's what I am saying. Wherever you written the digit value is always same. That is that face value. So what is the definition for face value? Means the digit itself. Face value means the digit itself. So here I written one of the number, that is 95,467. 95,467. I taken here 5 digit number. Now I want to know that what is the face value of 4. Face value of 4 I want to know. So what is the place value of 4? Yes, again the digit itself only. Which digit they are asking, the same digit is that answer. Okay, so face value of any digit is the digit itself. Okay, is it clear? Yes. So place value means what? It's the product of a number and its position. That one shows that place value of a digit. And here face value of a digit means the digit itself is that face value. So just like keep one thing in your brain, that is a face value. Face value means our face only. Okay, our face, wherever you will go, it doesn't change, right? So simply keep that one in your brain. So face value means the digit itself. So after that place value and face value, we have to learn about that types of numbers. Types of numbers. Types of numbers. So here I will show you that one of that flow chart. Okay, we have that so many types of numbers, no? So first thing is complex numbers. Complex numbers. So in that complex numbers, we have that real numbers and imaginary numbers. So what is that? Real numbers and here imaginary numbers. Okay, real numbers and here imaginary numbers. And again in that real numbers, we have that rational numbers and irrational numbers. Rational and here irrational. Okay, and again in that rational, we have that integers and fractions. Here we have that fractions and here integers. Okay, again in that integers we have that negative integers, 0, positive integers. Okay, negative integers, 0 and positive integers. Now again we have that positive integers. In that positive integers, what we have here, that is natural numbers. Only positive integers are there, means that is natural numbers. Okay, next 0 and positive numbers. 0 and positive numbers we will call them as whole numbers. Okay, including 0 we will call that 0 and positive numbers we will call them as whole numbers. Only positive numbers there, means those are natural numbers. And again in that natural numbers, we have that 4 sections. What are those? First one is even numbers. Next here odd numbers. Next thing prime numbers. And here composite numbers. Okay, so this is that flow chart, and this is very important flow chart. Why? Because if you learn this only this flow chart, you will know the total completely up to 10th class we have that real numbers. No, so up to there you will learn from this flow chart only. Okay, how means I will tell you that one. Once observe that flow chart carefully. So first starting with the complex numbers. So in that complex numbers we have that real numbers and imaginary numbers. Here only you can learn that the definitions also. Okay, so see that real numbers and imaginary numbers, and in that real numbers we have that is the combination of rational numbers and irrational numbers, we will call that as real numbers. Okay, next rational numbers. In that rational numbers what we have here, we have that fractional parts, and in the same way integers. So in that rational numbers what we have, fractional part numbers there as well as integers also there. So the combination of integers and rational fractions we will call that one as rational numbers. Okay, next again in that integers we have that negative integers, 0 and positive numbers. I mean negative numbers, 0 and positive numbers. Okay, again we will call about that each and every type of number individually. Okay, and briefly I will tell you that one. So just see that what is that flow chart. So in that integers again 0 and positive numbers, the combination of 0 and positive numbers we will call them as whole numbers, and only positive numbers we will call them as natural numbers. Okay, and again in that natural numbers we have to discuss about that even numbers, odd numbers, prime numbers, composite numbers. Okay, so this is that flow chart. Here first where we have to start means always we have to start from that natural numbers. Why? Because if you doesn't know about that natural numbers, you can't know about that complex numbers. Actually the flow chart is from complex numbers to natural numbers, but here you have to read, you have to know from that downwards to upwards. Why? Because natural numbers are there in that whole numbers are there in that integers are there in that where here rational numbers. Again in that rational numbers we have that fractions also. No, again that rational numbers, if you know about that rational numbers, then you have to learn about that irrational. After completion of those two we have to learn about that real numbers. Okay, next the combination of real numbers and imaginary numbers we will discuss about that complex numbers. Okay, that's why we have to learn from that downwards to upwards. So where we have to start? Yes, from that natural numbers we have to start. Clear? So what about that natural numbers? So the counting numbers are also known as natural numbers. So what is the definition for that natural numbers? The counting numbers. The counting numbers are also known as the counting numbers are also known as natural numbers. Okay, so this is the definition for that natural number. So what is the meaning of that definition? The counting numbers, in that word only there, the numbers which one we are using for counting, those all numbers we will call them as natural numbers. Okay, so here the set of natural numbers denoted by the letter n. Okay, the set of natural numbers denoted by the letter n. So here we have to write that set form. Okay, so here the numbers starting from 1, 2, 3 and so on. Why I written here starting number as 1? Why? Because whatever you may be, if you want to count anything, always you have to start with the number 1, right? That's why here natural numbers starting with the number 1. So here n is equals to 1, 2, 3, 4 and so on. Okay, so what is that smallest natural number? So here smallest natural numbers means what we written here, the first number, that is the smallest number no here, that is 1. What is the greatest natural number? Here I kept that and so on. And so on means what is the greatest number? We can't say that one, right? So here the greatest number is does not exist. Okay, so which means we can't say that what is the greatest number. So what is the smallest number means that is 1. Okay, so here we have to learn one thing, that is the number line. So on that number line, so the first number what we have to write here, what is the smallest natural number? That is 1, and here this is 2 and 3, 4, 5 and so on. So this is that number line for that natural numbers. Okay, once observe that here 1, 2, 3, 4 and so on. While you are moving from left side to right side, the number value is increasing. The number value is increasing. Okay, so on that number line, the number which lies to the right side of that given number is always greater than that given number. Okay, once again say that what I am saying is when you are moving from left side to right side on the number line, okay, the number value is in increasing order, no? That's why the number which is lies to the right side of a given number, right side of a given number means, for example, I take in here 2. So 2 is that given number. So I want to compare that 2 and 4. So which one is greater and which one is smaller? I want to compare that. So here 4 is there. Once observe that here 2 is there, here 4 is there. So 4 is lying right side of the 2. Yes or no? 4 is there to the right side of 2. That's why we can say that 4 is greater than 2. In generally also we know that 4 is greater than 2, right? So on that number line, like this way we have to check that. Okay, here the given number is 2 and I want to compare the 2 and 4. So where 4 is there, we have to see that 4 is lying left side or right side. Okay, right side of that given number. So here 4 is lying to the right side of that given number. That's why here 4 is greater than 2. Okay, now I want to compare that 1 and 2. What is that? 1 and 2, and I taken the given number is 2. Okay, the given number is 2. Now see that 1 is lying here. 1 lies to the right side or left side? Yes, 1 is lying left side of 2. Left side of 2 means when you are coming from that left side, here 4 is there. So 3, 2, 1. Once observe that number line from that right side to left side. Right side to left side means the number value becoming decreasing only, no? So that's why here 1 is less than 2. 1 is less than 2, or and in the same way 2 is greater than 1. In that way also we can write, no? Okay, like this way we have to compare that numbers on that number line. Okay, that's why we are saying that the greatest number always lies to the right side of that given number on the number line. Okay, here the point is on the number line I am saying. Okay. So after that we have to discuss about that successor and predecessor. successor and predecessor. So what about that successor? The next number of a given number. The next number of a given number, we will call that number as successor of a given number. Successor of a given number. Or else another definition also there. What is that? If you add 1 to that given number, if you add 1 to that given number, then you will get that the next number only, no? So we will get that next number is known as that successor of a given number. Okay. So for example, what is the successor of 4? Successor of 4. So successor of 4 plus 1 is equals to 5. So 5 is the successor of 4. 5 is that successor of 4. And what about that predecessor? What about that predecessor? Predecessor means the just before number of a given number. The just before number of a given number is known as predecessor. So just before number means if you subtract 1 from that given number, then you will get that predecessor. If you subtract 1 from that given number, then you will get that predecessor. So what is the predecessor of 4? Again I am taking the same number. What is the predecessor of 4? If you subtract 1 from that 4, then you will get that it's a preceding number, just before number. Okay, it's a preceding number or before number. That one we will call that predecessor of a given number. So here 3 is that predecessor of 4 and 5 is that successor of 4. Okay, so here which is the given number? Yes, 4 is that given number. Okay, to that 4. 5 is that successor and 3 is that predecessor. Is it clear? Now come to that natural numbers. Here in this set, which number is not having predecessor in a natural number? My question is, which natural number is not having a predecessor? Okay, so which number is not having predecessor? Just observe that 3 here. 3 is having a predecessor or not? Yes, that is having a predecessor. Why? Because 3 before 2 is there. So 3 minus 1 is equals to 2. So 2 is the predecessor of 3. Okay, come to that 2. Okay, so what is the predecessor of 2? 2 minus 1 is equals to 1. 2 minus 1 is equals to 1. So 1 is the predecessor of 2. Now come to that 1. 1 minus 1 is equals to 0. Okay, in that natural number set, do you have that 0? Here 0 is not there, no? That's why here which natural number is not having predecessor means that is 1. Okay, what is that digit? That is 1. So in natural numbers, 1 is not having predecessor. Okay, and here successor means you know that up to any number, what is the largest number we can't say, right? So every number is having that successor. That's why here we have to discuss about the main point, that is predecessor of a natural number. Which natural number is not having predecessor? So what is that number? That is 1. Okay, is it clear? So this is about that successor and predecessor of natural numbers. Okay, so in this video what we learned here, up to here we discussed about that place value, face value and types of numbers, flow chart we learned. Okay, so after that flow chart we learned about that the definition of natural numbers and set of natural numbers, and here we discussed about that predecessor and successor of natural numbers. So in that next video we will discuss about that even numbers, odd numbers, and here we get that 4 different parts in that natural numbers, even numbers, odd numbers, prime numbers, composite numbers. Those 4 also we will discuss in that next video. Okay, thank you.